This is a derivation of the quadratic formula. The quadratic formula basically solves the zeros of a quadratic relationship or the y-intercepts, basically. So if we have a quadratic in standard form, what we're doing to start is just setting the whole thing to 0. And we're trying to solve for x, and we could get one value for x if the parabola is touching the x-axis at one point, the vertex is touching the x-axis. We could get two solutions where the quadratic could pass through the x-axis in two locations, or we can have no solutions. We can have a parabola that opens up, which is above the x-axis, or opens down and is below the x-axis. Those are all possibilities, but we want to solve for x, but x is difficult to solve for because we have both an x squared and an x term in the standard form of a quadratic function. So we need to try and isolate x, but it's going to take some fancy footwork. The first step we are going to do is divide each of the terms by a to isolate x squared a little bit. That gives us x squared plus bx over a. And then if we subtract c over a, we can say that it is equal to negative c over a. Now, I'm leaving some space because we have to complete the square. Completing the square is basically going backwards from the square of a binomial so that we can get just x in one place. So we need to find out what value, okay, we can add and subtract onto this equation so that we can complete the square, so that we can go in reverse, go from this trinomial to the square of a binomial. Notice how the relationship between the middle term and the n squared term here, if I was to square x plus n, okay, notice how the third term is half of this and squared, right? 2n, well, this is just half of that, just n, and the n is squared. So I need to find what is half of b over a and then square it, right? So I'm going to say, I'm going to add b over 2a, square it. And then, because I can't just add something into an equation, I'm essentially adding 0 into the equation. I have to subtract it as well. B over 2a all squared. Now I'm going to keep this trinomial because it is going to give me the completed square, the thing that I want, basically my x plus n squared. And then I'm going to add the negative b over 2a all squared to the other side. So if I was to condense this x squared plus bx over a plus the square of b over 2a, okay, that would give me x plus b over 2a all squared. And that is equal to b squared. If I was to square this out, b squared over 4a squared minus c over a. So we're doing well so far. All right, what I want to do is I want to be able to subtract this b squared over 4a squared minus c over a. I need a common denominator, so I'm going to multiply the top and bottom by 4a. So that's the bottom in both of these terms is 4a squared. That's going to allow me to subtract this off. So I've got x plus b over 2a all squared. That is equal to b squared minus 4ac over 4a squared. If I take the square root of both sides, that will eliminate the square on the left, leaving me with just x plus b over 2a. And that is equal to the square root of b squared minus 4ac. But I can actually take the square root of the denominator. The square root of 4a squared is just 2a. Now I'm going to subtract the b over 2a from both sides. But I also have to remember, if I'm taking the square root here, I need to have plus or minus the square root, because that gives us the opportunity for two solutions. Whenever you take the square root of something, you need to have both the plus and the minus versions. So we have negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And that, of course, because the denominator is already common, we can write this as a single term. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of which is divided by 2a. That is the quadratic formula. And notice what's underneath the square root here. We know that you cannot have a negative number under the square root. So we call this b squared minus 4ac the discriminant. If b squared minus 4ac is less than 0, that's the 0 solution outcome. If it is exactly 0, root 0 is 0, and you're left with just negative b over 2a, a single solution, that's when the parabola is touching the x-axis. If b squared minus 4ac is greater than 0, that is the two solution case where the parabola will cut through the x-axis at two places.